J transform of a discrete time sequence x of n is defined as x of n z power minus n from n equal to minus infinity to plus infinity. This equation is known as Z transform of bilateral sequence. If I will split this in two halves, then it become n from minus infinity to minus 1 x of n z power minus n and plus n equal to 0 to infinity x of n z power minus n. So this is the expression for causal sequence. That is, if for x of n exists for n greater than equal to 0, then x of z is equal to summation of n equal to 0 to infinity x of n z power minus n. And this expression is for anti-causal sequence, right? And this is x of z. Now we are going to find the Fourier J transform of a causal sequence. Let x of n is given as 2, 3, minus 4 and 5, and this arrow indicate n equal to 0. Graphically we can represent this one as at n equal to 0 the sample value is plus 2, at n equal to 1 the sample value is plus 3, at n equal to 2 the sample value is minus 4, and at n equal to 3 the sample value is plus 5. This is n. Now we have to find the Z transform of this causal sequence. So we know that the Z transform of x of n is given as x of z equal to n equal to 0 to how many number of samples are here? 1, 2, 3, 4. 0, 1, 2, 3. 0 to 3 x of n z power minus n. Now you expand this, you'll get x of 0 plus x of 1 z power minus 1 plus x of 2 z power minus 2 plus x of 3 z power minus 3. X of 0 is 2, so we can put here 2, and at x equal to 1 this sample value is 3, so 3 z power minus 1. At x equal to 2 the sample value is minus 4, so this becomes minus 4 z power minus 2, and at x equal to 3 the sample value is 5, so 5 z power minus 3. So this is the solution, or this is the Z transform of the given causal sequence x of n. If you see this power series, for causal sequence the power of Z is always negative value, right? Now I'm taking the second example. Let x of n is given as 2, 3, minus 4, 5, and the arrow is given here n equal to minus 1. So graphically we can represent this one as at n equal to minus 1, x of n is plus 5. At n equal to minus 2, this is of minus 4. And at n equal to minus 3, this sample is 3. And at n equal to minus 4, the sample value is plus 2. So this is x of n. So here the samples exist from minus 1 to minus 4, right? Now we have to find out the Z transform of this sequence, and this sequence is the anti-causal sequence. So x of Z n equal to, what is the lower limit? Minus 4. What is the upper limit here? Minus 1. Right? X of n Z power minus n. Now if you substitute this, x of minus 4 Z power plus 4, then x of minus 3 Z power plus 3 plus x of minus 2 Z power 2 plus x of minus 1 Z power 1. And at n equal to minus 4, the sample value is 2, so 2 into Z power 4. At n equal to minus 3, so this is x of minus 3 is 3, so 3 Z power plus 3. At n equal to minus 2, this is minus 4, so minus 4 Z power 2. And at n equal to minus 1, the sample value is plus 5, so 5Z, right? So this is the Z transform of a given anti-causal sequence x of n. If you see this, the power of Z is positive value. So in any result, if I am getting the Z power as a positive value, I have to identify such kind of sequence as a anti-causal sequence, and if the power series is the negative value, then I can say this is the Z transform of a causal sequence. Thank you.